Hi and welcome to our next level 3 simultaneous equations video. In this video we begin a set of 3 videos focusing on the types of equations. Now in the 2D world we're solving 2 equations with 2 unknowns. When we solve these simultaneous equations you probably come across 3 scenarios. The first is where the lines intersect at one unique point, so we call it a unique solution and there is one solution. The next is where lines are the same line or the equations are the same. We say the equations are dependent and there's an infinite amount of solutions because they intersect at many places, infinite amount of places. And the last scenario is where the lines are parallel to each other. So there are no solutions, no points of intersection, and we say equations are inconsistent. Now in the 3D world, we're not solving for the intersection of straight line graphs. We're actually solving for the intersection of 3-dimensional planes. A plane is just a mathematical name for a flat surface. When we solve simultaneous equations in the 3D world, we still have the same 3 possible scenarios. A unique solution, equations could be dependent, or equations could be inconsistent. Let's explore these scenarios. So let's go back to scenario 1, a unique solution. We have 3 planes that intersect at a single point. Right, scenario 2 where equations are dependent. Now we have an infinite amount of solutions and the planes all intersect along a common line. So that's why we have an infinite amount of solutions, because they all intersect along this common line and there's many points of intersection. And scenario 3 is where equations are inconsistent, but there are 3 scenarios to part 3. The first of them is where we have no solution because the 3 planes are parallel to each other. The second is where we have no solution, and that's because 2 out of the 3 planes are parallel to each other, and the third plane is doing something else. And the final one is a little bit tricky. We again have no solution, and that is because each plane is parallel to the intersection of the other 2 planes. In other words, where 2 planes intersect, that third plane is parallel to that intersection. All right, let's see if we can explore these with a bit more detail. So once again, let's come back to our unique solution. Again, this is where all 3 planes intersect at a single point. When we talk about dependent equations, what we mean by this. Let's have a look at this example. If you look at the first equation and the second and I add those, x plus 2x make 3x. 1y, take away 3y, leaves negative 2y. 1z plus 4z is 5z. And 1 plus 6 is 7. So the third equation is actually depending on the other 2. By adding the other 2, I get the third equation. That's what we mean by equations are dependent. One equation is dependent on another or the other 2 equations. All right, now let's explore inconsistent equations. The first scenario is where we have 3 planes that are parallel. Now let's have a look. We have 2 equations which are the same and the constant is different. If you actually look at the third equation and divide everything by 2, you'll see it's the same as the first 2 equations, but again the constant's different. So for this scenario, the equations are the same, but the constants are all different. Second type of inconsistent equations, you will see this is 2 parallel planes, and that's because 2 equations are the same, but again the constant is different. The third equation does something different. And finally, for this last scenario, this is what's going on. You'll see that if I took the first equation and doubled it, took the second equation and times everything by 5, then you will see that I can add the first 2 equations to get the third equation. However, again, we don't have dependent equations because the constant is different. There's that inconsistency. Right. Thanks so much for tuning in.